This tutorial is about solving linear algebraic equations with one variable, and we're going to have a look at what I call the seesaw method. I don't know if anybody else has ever used that term. I thought I'd made it up, and I'm pretty sure I did. However, when we say solving for linear algebraic equations with one variable, that means we're actually going to come up with the answer. Now, very briefly, in a previous tutorial, we looked at how we could get infinite number of answers for linear algebraic equations with two variables. With these, you can only get one answer. So let's have a look at how we go. First of all, this whole thing about the seesaw method, I'll explain it to you very carefully. You all know what a seesaw is. You can see the seesaw here is not balanced. The children on the left seem to be heavier than the children on the right, or they may be sitting in different positions, but that seesaw is not balanced. Now, very often, if you look in physics textbooks, you'll see things like this. This is a good seesaw to look at. Can you see that the seesaw is balanced? So that tells me that's what is on the left here balances with what's on the right. This thing here that we call the fulcrum, that is our equal sign. So this equals that. So what I know is if I get another ball and I put it over here, it'll bring the seesaw down. But if I get another ball of exactly the same weight and put it back here in the same position, it'll fix the problem. You agree? And if I put another ball here, another ball over here, a really heavy one, it would bring this side of the seesaw down. But as long as I put the same heavy ball over there, it will fix it up again, and then our equal sign will be okay. So what that means is if you do something on one side of a seesaw and you don't do it on the other, the seesaw won't balance anymore and your equal sign won't work. So let's have a look at an example here. 3x plus 2 equals x plus 3. Here's our seesaw. There is the fulcrum, and we know that what's on the left is the same as what's on the right. At the end, I want to have something that says x equals and my answer. That's what I'm looking for. Because the question here really is, there's a number, if you multiply it by x and you add 2, it's the same as taking that number and adding 3. Now you can start guessing and go, well, let's try 3. X is 1, 3 times 1 is 3, plus 2, and then x is 1 plus 3 is 4. That doesn't work. The seesaw method works even with the most tricky ones. So we want to end up with x equals. So what we're going to do is anything with x, we're going to collect on the left-hand side of the seesaw. And everything with that just has known numbers, we're going to collect on the right-hand side. How do we do that? Let's have a look. Here is a plus 2. I don't want it there. So have a look at what I do. I subtract 2. What have I just done? I've taken something off this side of the seesaw, and it's made it not balanced anymore. How do I know it was balanced? Because I had an equal sign. So what do? I fix that by doing exactly the same thing on this side of the seesaw. So I'm going to subtract 2 there, subtract 2 there. Let's have a look what we end up with. Right, that 2 minus 2 is 0. So on the left, I've only got 3x. 3 minus 2 is 1. And I've still got the x there. Now we're going to do the same thing. What have I got on this side of the seesaw that I don't want here? Well, I want that because I want an answer at the end. But this x needs to disappear. And the way I make it disappear is by subtracting x, because x minus x will give me 0. But I've just messed up the seesaw. It's out of balance, so I need to fix that by doing the same thing on the left. 3x minus x will give me 2x. X minus x will give me 0. Right. 2x equals 1. Still not quite there. You can guess it by now. X is a half, you can see. But how do we do this? We divide both sides by 2. I divide this side by 2 and I divide that side by 2. And I get x equals a half. Or x is 0.5 is good also. Right, let's look at another example. Same thing again. We've got our equal sign, which is where the seesaw is balanced. Whatever's on the left is the same as what's on the right. There's a number called x. We're not sure what it is. If you multiply it by 10 and subtract 6, it's the same as multiplying it by 5 and adding 2. Right, let's go. We want to get rid of the 6, so we subtract 6. But to keep the seesaw balanced, we need to subtract 6 here too. So these two will cancel out, and I'll end up with 10x on the left. And on the right, 2 plus 6 will give me 8. There's the 10x, that's gone. There's the 5x, and that's become plus 8. Now, same again. 5x, don't want that here. I'm going to subtract it. But I need to do the same on the left to keep the seesaw balanced. 10x minus 5x is 5x, and 5x minus 5x is 0. And what we now need to do is divide by 5 on the left and divide by 5 on the right. So end up with x is 8/5. And we can change that to a mixed number, which is x equals 1 3/5. One more before you try some examples of your own. 4y plus 2 equals 12y. Now, since I've been doing these things for years, I would normally, if I was trying to find out how much y was, I would actually collect all the y's on this side and the numbers on this side, because it would be a very quick step. I'd just have to move that one there. 12 minus 4 would give me 8. But so that you can learn about the seesaw method, I'm going to do it the hard way. However, in future, you know, I always say to do things the easiest way, as long as they're mathematically correct. There's a 2 over there. I don't want it. So there it is. 1, 2, 3, minus 2. Seesaw's unbalanced. Need to do that there. That 2 is going to cancel that one out. So on the right, we're going to end up with 12y minus 2. So that's gone. 12y minus 2. That 12y needs to go because I want it on the left. So I'm going to subtract 12y. But to balance the seesaw, I've got to do it on the left. So see that again. Subtract 12y there, but fix it. Fix the unbalance that you created by doing the same on the left. 4y minus 12y is minus 8y. And that cancels out, and we end up with minus 2. Now, you've got minus 8y is minus 2. You can probably work out, if that's the case, then plus 8y would be plus 2. Or you could just say, right, I'll multiply by minus 1 on the left and minus 1 on the right. So I'll do the same thing on both sides. They'll both become positive. There's so many ways of doing it. You could divide by minus 8 on both sides. Because minus 8 divided by minus 8 here would give you y, and minus 2 divided by minus 8 would give you the answer. But let's do this. Let's change it to 8y equals 2. Now we just need to divide by 8 here and here. So that 8 divided by 8 would give you 1. And 2 divided by 8 gives you 2/8. And you've probably spotted that 2/8 is another way of writing a quarter. That could be a quarter. Right, here are some examples for you. They're all fairly straightforward. The last 3 have fractions in them, which tend to make things a little bit more messy, but the maths is still the same. So when I put the question up on the screen, pause the video because it'll take you some time to solve, and then continue when you think you've got your best answer. X plus 6 equals 2x minus 2. Pause the video, and when you're ready, continue. Right. The 6 needs to go. I want only x's on the left. Agree, so let's subtract 6. But if we do that, the seesaw is just tipped. Let's fix that and subtract 6 there. What will that give you? On the left, you'd have x, and on the right, you'd have 2x minus 8. We don't want this here. We want it there. Well, it doesn't actually really go there. We balance it. So if we don't want this 2x there, let's subtract 2x. But if we do that, what do we need to do? Do it on the other side. And we end up with that. X minus 2x is minus x. This 2x minus 2x will cancel out, and on the right we'll be left with minus 8. So minus x equals 0 minus 8, or x minus x equals minus 8. That's 0 from there. You don't have to put it there. I don't know why I did. Just to show you, I suppose. If minus x is minus 8, then x is 8. Right. Question number 2. Here we go. X plus 10 equals 2x plus 6. Pause the video, and when you are ready, carry on. I want to get rid of this 10, so I'm going to subtract 10. And then to keep the seesaw balanced, I'm going to subtract 10 there. That'll give me x equals 2x, and 6 minus 10 is minus 4. Now, I want to get rid of this, so I'm going to subtract 2x there. To balance the seesaw, I need to do it there. X minus 2x on the left would give me minus x. This will cancel out. So on the left, we'll end up with x minus x, and on the right, these two will cancel out, and we end up with minus 4. If minus x is minus 4, then x is 4. So, x plus 10 equals 2x plus 6. What number would work there? 4. You could try it. 4 plus 10 is 14. 2 times 4 is 8 plus 6 is 14. Yes, it works. X minus 4 equals 2x plus 5. Pause the video, and when you're ready, carry on. Right, we have a minus 4 here. Now, to get rid of this minus 4, we have to add 4. So if you subtracted 4 there, minus 4 would give you minus 8. You need to add 4 on the left. To keep the seesaw balanced, we need to add it there as well. Okay. These two will cancel each other out. Minus 4 plus 4 will give me 0. Well, that was the whole point of why we did it. And on the right, we'll end up with 2x, and that will be plus 9. See that? 5 plus 4. We end up with x equals 2x plus 9. We don't want that there. So we are going to subtract 2x. We need to do the same on the left. X minus 2x is minus x. That cancels that, and we end up with minus x equals plus 9, or just minus x equals 9. If minus x is 9, then positive x will be minus 9. Or you could have said, I'll multiply by minus 1 there and there. Question 4. Minus 2x equals x plus 3. 10 minus 2x equals x plus 3. Pause the video, continue when you're ready. Let's get rid of the 10. Now it's a plus 10. To get rid of it, I need to subtract 10. I've just added something on the left side, or taken something off the left side of the seesaw. To fix it, I must do the same thing on the right. 10 minus 10 is going to give me 0, which is what I wanted. 3 minus 10 is going to give me minus 7. So, got rid of that. There's the minus 2x still there. There's that x still there. And 3 minus 10 is minus 7. Now, we want to get rid of this x. So we're going to subtract x over there. We're going to subtract x over there. That will get rid of that. Minus 2x minus x is minus 3x is minus 7. Now, because it's very easy, I always do this. Minus 3 on the left is minus something on the right. I just change them both to positive. 3x is 7. Now I want to get rid of this 3. I can't subtract because those two are multiplied together. So I divide by 3 on the left and the right. See, I divide 3x by 3 and I divide 7 by 3. This 3 divided by 3 is going to end up with 1. So we're left up with x is 7/3. And if we write that as a mixed number, 2 1/3. Number 5, 3x plus 4 equals 5x plus 2. Pause the video, continue when you're ready. Right, I jump straight into it. I can see I don't want that 4 there, so I subtract 4. I have to do it there too, though. Why did I subtract 4? You know that we want to get rid of that 4. So 4 minus 4 will be 0. So we're left on the left with 3x equals 5x, and 2 minus 4 is minus 2. We don't want this here. We're going to move it by subtracting 5x, and we need to balance the seesaw by doing it on the left. We end up with minus 2x equals minus 2, which means 2x equals 2, and x is 1. Right, next one. 4x plus 8 equals 20 minus 2x. Pause the video and continue when you're ready. I'm going to get rid of this 8 first, so I'm going to subtract 8. But to do that, I need to do the same on the right. Now, I just want you to have a look. I've written minus 8 here. I'm also writing them as superscripts at the top so they stand out. You could write them just like normal numbers there if you like, but at least you can see what you're doing here. You could also write the minus 8 next to the 20, since that's where you're going to be subtracting it from. It doesn't matter really whether you write the minus 8 there or there. All right, let's do it. We end up with 4x equals, or 20 minus 8 gives you 12, and the minus 2x is still there. Now, this minus 2x needs to go, so we are going to add 2x. Here we go. And we need to do the same on the left. And now we're going to end up with 4x plus 2x will give us 6x. 12, minus 2x plus 2x x on the right will give us nothing, and we end up with 6x equals 12. And if we divide by 6 on the left and the right, we get x equals 2. Okay, 7x plus 6 equals 9x. Pause the video, and when you're ready, continue. I would, because I've been doing these so long, I would actually collect the x's on the right-hand side, because then you only have to do one step. But we're going to, just so you can see how things work, we're going to do it the hard way. Remember, in future, always do it the easiest way. Get rid of the 6 by subtracting 6, and then we need to do it on the right as well. And that will mean we end up with 7x equals 9x minus 6 that we brought across from there. I need to get rid of this 9x. I'm going to subtract 9x there or there. You see, it doesn't matter. If you put it there, you still go 9x minus 9x. If you put it there, you still go 9x minus 9x. But I also then have to do it on the left. 7x minus 9x gives me minus 2x. And those two cancel out. And on the right, I'm left with only minus 6. All right, if I've got minus on the left and minus on the right, I'm just going to change them. So instead of having minus 2x is minus 6, I'll make it 2x equals 6. And now I'm going to divide by 2 on the left and the right. So this 2 divided by 2 will give me 1. So I only have the x, and 6 divided by 3 is 2. Question 8 has fractions in it. It might be a bit more messy, but the method is pretty much the same, guys. X plus half of x plus 4 equals a quarter of x plus 6, or x over 2 plus x plus 4 equals x over 4 plus 6. Pause and continue when you're ready. Right. On the left, I have a 4. I don't want it. It's a plus 4, so I'm going to need to subtract 4. But in order to keep the seesaw balanced, I need to do it on the right. So what comes out of this as a result? On the left, we end up with x over 2, and that disappears. On the right, we end up with x over 4, and that 6 minus 4 left me with 2 over there. Now, to get rid of this x over 4, or a quarter of x, I'm going to need to subtract a quarter of x. Now, I haven't written it up as a superscript because I can't do that when it's a fraction, unfortunately. So, see that to get rid of this, I subtract it. But of course, I need to then also do it on the left. So I'm subtracting a quarter of x on both sides. Now, let's have a look. I've just copied that across to a new page. It's the same thing. I haven't changed anything. Half of x minus a quarter of x. What is a half of x minus a quarter of x? It's a quarter of x. If you have half of a pizza and you take away a quarter of a pizza, you end up with a quarter of a pizza. And these two will cancel each other out. So we end up with a quarter x equals plus 2, or quarter of x is 2. Just take the plus sign away. You can probably reason it out, but I'm going to show you how to do this with this method. To get rid of this 4, you can't subtract 4 because they're not added together, they are multiplied. So I'm going to multiply the left side by 4 and the right side by 4. See that? I'm going to multiply this by 4 and that by 4. If I do that, this 4 divided by that 4 gives me 1, and I end up with x equals 8. Right, a third of x plus 9 equals x plus 6. Pause the video, and when you're ready, carry on. Right. Here's a 9. We don't want it there. Let's subtract it, but let's balance by doing the same there. And we end up with a third of x equals x minus 3. Now here we have an x that we don't want, so we subtract it, and we need to do it over there. Now, just in terms of the subtraction here, if you have a third of x and you subtract a whole x, let's think of it in a number line. You jump up to a third, and then you jump back a whole number. Now, how many thirds are there in a whole number? Well, let's have a look. So there's 3 thirds. So a third of x minus x is 1/3. There we go. Minus 1, 2, 3. We end up at minus 2/3 of x. That cancels out, and on the right we just have minus 3. And I can't believe I'm getting so many examples where this happens. We've got a negative something on the left and a negative something on the right. You could just change them if you wanted to. I'm going to leave them this time. And I'm going to show you, not a trick, I'm going to show you how to do this. This is tricky now. I could change those to positives, but how do I get rid of this 2/3? How do I get rid of the 2/3? What we do is we use a trick called, not a trick, we do this. It's called multiplying by the inverse. Now the inverse of minus 2/3 is minus 3/2. Minus 3 over 2. So have a look at that. 2/3 are multiplied by minus 3/2. Because I now know that 3 and that 3 will cancel, that 2 and that 2 will cancel, and I'll be left on the left-hand side just with x. But I need to do the same here. Now there is a mistake in the next slide, so right. So let's do it. That divided by that the 2's gone. That divided by that, 2's gone. And a minus times a minus is a plus. So we're looking just at the left side first. And we end up with x. On the right-hand side, we end up with minus 3 times minus 3 is 9 halves. And if we change that to a mixed number, we get 1, 4 and a half. Or 4.5. Right, number 10. 5x minus 6 equals a third of x. Pause the video, and when you are ready, continue. Yep, straight into it. I want to get rid of that 6. So I add 6, but I need to do it on the right. So I end up with 5x equals a third of x plus 6. Because I've added 6 there, that plus 6 comes down here. Now we want to get rid of the third of x. So we are going to subtract by, we're going to subtract a third of x on the right. But we also need to do it on the left. See what I did? I subtracted this on the right, and I subtracted it on the left. Right, now, if you have 5 pizzas and you give away a third of a pizza, you end up with 4 2/3 of a pizza. And that would be 4 2/3 of x. Agree? That minus that cancels out. We end up with 6 on the right. Or just 6 like that. Now, okay, so 4 2/3 of x is 6. That's a little bit tricky. So what is x? How do you work it out? What I'm going to do is I'm going to change this to a mixed number. And then we're going to use that multiplying by the inverse again. So let's change this to a mixed number. It's 14 thirds. I swap those 4 pizzas for thirds, which gives me 12. And then there's another 2 there, 14 thirds. I'm going to multiply by the inverse. So I'm going to multiply by 3/14. See what I've done? 14 thirds multiply 14 thirds x multiplied by 3/14. And then I've got to do the same on the right. Now, that's the whole point of this. 14 cancels with 14, 3 cancels with 3. On the left, I end up with x. And on the right, 6 times 3 is 18. X equals 18/14. Now I'm going to change it to a mixed number. X equals 1 2/14, which means x is 1 1/7. Right, that's it for that tutorial. If you didn't quite get it, watch it again. That's the whole point of it. You can always access this video when you need to. Come back to a specific place. You don't have to watch the whole thing from the beginning. I hope this helped you in becoming a genius with algebra.